should be 1.5 hour. Pili mo unsa oras sa magsugod. 7:30 to 10:30. Unsa oras sa magsugod? 7:30. Pili mo sa oras sa 7:30 to 9. 7:30, 8 ba? 8:30 or 9? May tao? Si Dupla.
Yes, miss.
Dupla, unsa orasan nimo gusto magsugod ang test next week?
Kuan, miss. Pura na ko, miss 8, miss.
Sugod ta 8. Sige. Okay ra? So we will have the test. Okay ra ka Friday?
Yes, miss.
Sige. Mutuman si Dupla. So we will have the test for reading material 1 next week, Friday, at 8 o'clock. 8 to 9:30. Okay, 1.5 hour man siya. So what we will do today is to answer the assignment na ay na-assign. To answer, please present your assignment. For katong dili kinahanglan computation, I hope you prepared a visual for your presentation. I say for your answer. Wala gani okay ra. However, next time, everyone should prepare a visual ha kay some of us um, might have internet problem and we won't be able to hear the presenter clearly. At least naa siya visual. Napaka-isulti sa imong mga classmate Tukla. Wa may tao. Namahaw ka na ba? Naa si Apura.
Yes, miss.
Okay, mo answer na ka.
Yes, miss. Ready sa na, miss.
Ox, salamat.
Okay na, miss.
Okay, sige.
Okay, good day everyone. I am Lizelle Apura and my assigned question is sketch the atomic structure of copper and discuss why is it a good conductor and how its structure different from of germanium, silicon, and gallium arsenide. So this figure illustrates the atomic structure of copper, which contains the number of 29 protons, 35 neutrons, and 29 electrons. So the number of valence electron in the outermost ring is only one. So which implies that the copper conducts easily and that makes it a good conductor. And then this figure represents the atomic structure of germanium, while this figure represents the atomic structure of silicon. So we can see that both have 4 valence electrons in the outermost ring, so which implies that both can be either conductive or insulating materials. So we can say that both germanium and silicon are semiconductors. On the other hand, um, gallium arsenide is made up of one atom and two elements, which is the gallium and arsenic. So if gallium and arsenic reacts together, their valence electron will share to each other. So as we can see here in the figure, gallium has three valence electron, while arsenic has five valence electron. So that makes them a compound semiconductor when both their valence electron share. That's all, Miss.
Check. Uh,
Thank you.
Sakto siya. Actually, for electrical behavior of elements, the the valence electrons dictates how they would behave electrically. Sakto to. Copper has one valence electron. Next one, Rales. Si Honrales. Sabihan nato kay ulan ra baron. Basin. Kay pa si Honrales. Volante. Next. Kajut sa. Minyosa. Na si Honrales.
Miss, naa siya, miss. Nag-prepare siya kay
Aw.
iyang PPT.
Sige, sige. Hulaton sa nato sila. Na si Volante. In case madugay si Honrales. Kachot. Madugay siya kachot. Kasi Volante wa.
Na, miss.
O sige. Ikaw sa. Dahil balik ko na to si Honrales. Volante sa. Dahil we'll go back to
Okay, miss.
Honrales.
Good morning, everyone. I am Jonawel A. Bulante, and I am assigned to report for number 4. So, for question A, how much energy in joules is required to move a charge of 12 microcoulomb through a difference in potential of 6 volts? So, first, let's identify what are the given and what is asked in the problem. So, the given are Q, which is the charge, is 12 microcoulomb, and the voltage is equals to 6 volts. So what is asked in the problem is the energy in joules. So in this question, in this problem, we will use this formula. Voltage is equal to energy over coulomb, I over charge. So since energy man ang itong ipangita, we will derive this formula into this one. Energy is equal to charge times voltage. So substitute the values, which is the 12 microcoulomb times 6 volts. And we all know that micro is has a prefix of 10 times 10 raised to the power of negative 6. So 12 times 10 raised to the power of negative 6 coulomb times 6 volts. And we now obtain an energy of 7.2 times 10 raised to the power of negative 5 joules. So for B, find the energy in electron volts. So so kaning energy ato i-convert into electron volts. And note that 1 electron volts is equal to 1.6 times 10 raised to the power of negative 19 joules. So can now convert this joules to electron volts. So 7.2 times 10 raised to the power of negative 5 joules times 1 electron volts over 1.6 times 10 raised to the power of negative 19 joules. So cancel ang joules, ang mabilin kay electron volts. So divide, and we now get an answer of 4.5 times 10 raised to the power of negative 14 electron volts. So, mga to, miss. Thank you, miss.
Check. That was not presented in my discussion, ha? Pero appear siya sa reading material 1. The energy that we would, of course, it would require a certain form of energy to make the carriers move. Usually, it is the electrons that move. In that case, the energy is a voltage or a potential difference. Another form of energy, of course, is heat para mudagan ng electron. So usually, we use application of voltage. Thank you. Next, si Honrales. Yan siya.
Makita na, miss.
Yes.
So, question 2. In your own words, define an intrinsic material, a negative temperature coefficient, and covalent bonding. So, an intrinsic material or undoped material is any semiconductor with no impurities or lattice defects. So, there is a process called doping wherein you add an impurity to a pure substance to alter its properties such as conductivity. So an intrinsic material is undoped, so it is pure and it is chemically pure. So negative temperature coefficient refers to materials that experience decrease in electrical resistance when their temperature is raised. So semiconductor most semiconductors are when heated their resistance decreases. So that's a negative temperature coefficient. So lastly, covalent bonding, it is a chemical bond that involves sharing of electrons between atoms. So that's it, Miss.
Ox, check. Check. It is worth mentioning also that in covalent bonding, it is the valence electrons that are shared. Ox, and also, I mentioned, negative temperature coefficient. Sakto po siya. When the temperature increases, mudako ang temperature, magamay ang resistance. That's negative temperature coefficient. On the other hand, kung mataas ang temperature, mataas ang gani ang resistance, that's called a positive temperature coefficient. Ay negative na positive. Kasi may conductors of a negative temperature coefficient. Okay, na si Morales. Then, Fernandez, Athena. Si Fernandez. Wala.
Nakita ra, miss.
Yes. Oh my God, may nga klase. So, bang klase. Tabi, lagi sila. Ako na lang i-imagine.
So good morning, everyone. I'm going to answer number 5 in the reading material 1, which is all about semiconductor diodes. So problem number 5 states that if 48 electron volts of energy is required to move a charge through a potential difference of 3.2 volts, determine the charge involved. So first, let's identify the given. So we have 48 electron volts and 3.2 volts. So the problem asks for the charge involved in here, which is denoted by Q. And the formula we're going to derive this since we're looking for the Q. So in order to get the Q, we're going to divide both sides with V in order to isolate Q. Then we have this to get the charge. So take note that the units involved in here are for energy, which is denoted by W, we use joules, charge for coulombs, and voltage, which is in volts. So in order to convert these electron volts, we know that in every 1 electron volt, there is 1.6 times 10 to the negative 19 joules. So where did this come from? This comes from the equation, this one for energy, which we substitute the charge of electron, which is 1.6 times 10 to the negative 19 coulombs, then multiplied by 1 volt. So this 1 volt is equals to 1 joule per coulomb. And in here, it means that the one potential difference means that there is 1 joule of work done per coulomb. So now we're going to convert our 48 electron volts to joules by simply multiplying it with 1.6 times 10 to the negative 19. Then we have 7.68 times 10 to the negative 18 joules, which we're going to substitute it to the formula to find the charge. Now we have our energy, we have our volts, so simply substitute it. And we're going to use our calculators to solve for it. Then we have 2.4 times 10 to the negative 18 coulombs, which happens to be our final answer for this problem. That's all, Miss.
Off check. Oh, bongga. Thank you for the backgrounder, Sad. In-ana siya. Uh, Again, uy, ako isun. It would take an application of energy to make the charges move. And when the charges move, it is the electrons that move. And mauna na siyang kuryente because current is the rate of change of moving charges. Mauna na siyang kuryente. So when you are using electricity at home, natay current, and nagpagandagan diha ang electrons. So after Fernandez, Niniria. Na si Niniria.
Namis. Makita ra, miss?
Yes. Lenny,
Okay.
imuhang president.
Di, miss.
Aw.
Charot.
Aw.
Okay.
Di man ng president si Sarah.
Okay, so good morning, everyone. So today, let's tackle about the fundamentals of electronic circuits, basically semiconductor diodes. Okay, I am your presenter. Okay, so my problem assigned is that about N-type and P-type materials. Okay, number 7 is describe the difference between N-type and P-type semiconductor materials. So first, before we go on, so let's talk about what is the N-type and P-type in order for us to have an idea of what we are going to talk about, right? So N-type material, what is an N-type material? It is an intrinsic semiconductor that has been impurity doped. So when you say intrinsic, it means that it is distinct, or it means it is made of only a single element of atom. And then Group 4, silicon contains the 4 valence of electrons. So, mga tana di ka, asa din gikuha di kaning mga group. So, gikuha ni siya sa table of elements in which ang kanina mga elements kay rich in electrons like kaning silicon. And then so I think there are 14 of them elements that have a rich electron. Right. So let's continue. So when a small amount of phosphorus is introduced to a pure silicon crystal, one of the phosphorus valence electrons becomes free to travel around the surplus electron. So this will be called free electron. So right. Okay. So this is before we proceed, why it is called an n-type, because it is a donor of impurities donate negatively charged electrons to the structure. So kani silicon intrinsic, di ba? Pure siya. So it has 4 valence of electrons. And then the process uh, of adding impurities. So mo ta na mo unsa ng impurities. So mo to ang n-type and p-type. Okay, so let's focus on n-type. So the process of adding impurities by the semiconductor is called doping. So mo ni siya gitawag na doping kanang mag-add siya og impurities sa usa ka element. Right, so this silicon. While the phosphorus, since it belongs to group 5, so it has a 5 valence of electrons. So and then it recombine the structure. As you can see, na ay free electrons since ang silicon has 4 and then a phosphorus have 5. So na siya extra. So meaning to say, ang n-type excess 1 electron is required. Okay? So mo na siya. Excess of 1 electron. Next is what is an p-type? Okay, a p-type is semiconductor is an intrinsic also that has been doped with boron. Okay, sa kaning boron, indium, since di ba group 4 silicon it contains valence of electron. So kani gitawag ni sila trivalent impurities since it belongs to group 3 and has 3 valence of electrons only. Sige, in order to matawag siya na p-type material, it will be needed to have a means of deficiency of 1 electron. So, insufficient. And that becomes a new hole. Right? Okay. What is called the p-type? Because semiconductor having holes majority as the carriers and electrons and the minority tong free electrons. Right, so this is our example. Silicon, as we all know, has 4 valence of electrons. And then the boron 3 valence of electrons since it belongs to the group 3 means trivalent. Ang katong phosphorus, kanto siya pentavalent. I means have 5 valence of electron. So, gidope siya and then combine to the structure. As you can see, since it is insufficient or deficiency siya 1 electron, so it becomes a hole. Alright, so let's focus on what is their differences. Alright, so n-type semiconductor, we know that impurities such as arsenic, antimony, phosphorus, and bismuth, these elements having 5 valence electrons. So n-type semiconductor is pentavalent, 5 valence of electrons, while the p-type semiconductor such as aluminum, gallium, indium, 3 valence of electrons, which means is trivalent. Okay, so the impurities. So there are 2 types of impurities, the n-type and p-type. So kung mingo kag n-type, the donor atom. Since katong ganong donor atom siya, kay katong excess na 1 na electron, and then ang p-type semiconductor mo siya acceptor atom since ang katuyang deficiency na hole, it becomes now may mong acceptor. And then the next thing is semiconductor, it talks about free electrons. P-type means holes. And in this case, n-type is a low if the majority of the carriers moves. Since, di ba, ang electrons kay it orbits around the atom, so primarily siya mag-move. So from low potential to high potential. While ang p-type kay from high to low potential. And then lastly, The donor energy level for the N-type, and for the P-type is the acceptor energy level. That's all. Thank you, Miss.
Check. Dili mo dagan si Sarah as president, ha? Joke lang, dayon. Right. The N-type and the P-type material are already extrinsic materials because they are already doped. N-type has excess electron in, and P-type has deficiency in electron.
Is Miss, mahimor siya extrinsic once na ma-dope siya.
Check. Intrinsic siya kung wa pa siya mag-dope. And ang katong gidope na material for N-type are called donor atoms. And katong para sa P-type are called acceptor atoms. Check. Ito ba? Ito po ano siya. After ni Maria Villaber. Si Villaber. Yeah.
So, good day, everyone. So, this is my question. Describe the difference between majority and minority charge carriers. Majority charge carriers. The carriers that are present in large quantity are called majority charge carriers. Minority charge carriers. The charge carriers that are present in a small quantity are called minority carriers. So the majority charge carriers carry most of the electric charge or electric current in the semiconductor. So hence majority charge carriers are mainly responsible for electric current flow in the semiconductor. The minority charge carriers carry a very small amount of electric charge or electric current in the semiconductor. So in this picture, the N-type semiconductor has an excess of negative charge carriers or free electrons. Hence, the free electrons are the majority charge carriers in an N-type semiconductor. The free electrons or majority charge carriers carry most of the electric charge or electric current in a N-type semiconductor. While in a P-type semiconductor, there's an excess of positive charge carriers or holes. Hence, holes are the majority charge carriers in a P-type semiconductor. The holes or the major charge carriers carry most of the electric charge or electric current in a P-type semiconductor. So in a P-type semiconductor, there's a very small number of free electrons is present, making free electrons the minority charge carriers in a P-type semiconductor. The free electrons or minority charge carriers carry only a small amount of electric current in a P-type semiconductor. So that's all.
Check majority and minority. For a P-type material, for example, the majority carriers are the holes. Of course, naagahapoy nasaag nga electron na naglakaw-lakaw. Pero gamay ra siya. So they are the minority charge carriers. The N-type, daghan excess electron. E mao man jud na siya ang ideal, di ba? So the electrons are the majority carriers. So sa high dai masaag nga holes. They are called a minority charge carrier. These carriers can also form a current, pero very cute, kamay kaayo. Mostly are from the majority charge carriers. Okay na, Villaver, thank you. And after Villaver, Minyosa.
Yes, miss. Madawag lang ko, miss.
Yes, very clear.
Sadya sa miss. Naghanap ako. Um, Nakita lang kong gi-share.
Yes, makita.
Good morning, everyone. I am tasked to describe the conditions established by the forward and reverse bias on a PN junction diode and how the resulting current is affected. Then combine both materials, the N and P, form a diode. Then inside a diode, we have the two leads, the anode and the cathode, which is connected to some thin plates. And between, there's a layer of P-type, ani, silicon on the anode side, kaning positive is mo ni ang anode. Then ang N side, ang cathode side. Then after doping an intrinsic semiconductor material, usually the silicon, since silicon is the most used semiconductor in the electronics industry. Ang kani siyang tungaan ni mo ni ang PN junction, which is formed at the boundary between the P region and the N region. And the majority of the carriers sa hole ay sa P region is ang holes, and sa other side the N is ang free electrons. Then when the P junction is formed, the free electrons and in the N region begin to diffuse across the junction and combine with the holes in the P region. So, ang kaning electrons is mo transfer siya dire sa P region, and this makes the N region lose free electrons and creates a layer of positive charges near the junction, kani. And then as the free electrons combine with the holes in the P region, dili, the P region also loses holes and creates a layers of negative charges near the junction, kani. These two layers of positive and negative create a region where charge carriers are depleted. This region is called the depletion region. Kani, kani. Then, if we connect a voltage source across a diode, the anode connected to the positive, kani, positive sa anode, i-connect nimo ang positive sa anode, and the cathode to the negative, this will create a forward bias and allow the current to flow. This will create a forward bias. The voltage source has to be greater than 0.7 volts barrier, otherwise the electrons can't make the jump. Then when we reverse the power supply, ang kanina siyang P at ay no. When we reverse the power supply, so the positive is connected to the N type cathode and the negative to the P type anode. The holes are pulled toward the negative electrons and electrons are pulled toward the positive, causing the barrier to expand. Therefore, the diode acts as an insulator to prevent the
Napupull siya or nahuman na?
manamis.
Oh, now, pwede i-present mo balik, Minyosa? Nala ko i-note ko dyan. Ito.
Yes. Ay, ang kuan miss katong
Ato yung,
pictures.
ang picture.
Ah.
Notice in the figure, kanang dako, kanang naa sa taas nga PN, then there is an applied voltage. That's only for illustration purposes. when we actually use a diode, tanawa ang kanang naa sa ubos, kanang dako. When we are actually using the diode, there should be a resistance. Do you see the resistor? There should be a resistor when we actually connect the diode. Because if it is forward bias, current would flow, right? It would be like an on switch and an unidirectional on switch. Kung walay resistor diha, maguba imong diode, sometimes maguba sa imuhang voltage supply because of the very large current that will flow. Kung short circuit man siya, there should be a resistor. Just like uh, it is shown there. Dili kanang nasa taas nga gamay nga gibutangan siya voltage. Kuha na siya for illustration for purposes forward and reverse. Pero kung actual na siya nga itaod ha sa circuit, there should be a resistor in series with the diode. Or to make sure lang that the current that would flow through the diode when it is on should be limited. Check, thank you. Dito for illustration na dyan ha, na karang idiretso o apply ang voltage. There should be a current there. Okay na? Thank you. Minyosa. Sakto na imo lagi. Anaw po ma. After Minyosa is Tales.
Ay, Miss. Ay kanang okay ra walay kuan, Miss. Presentation, Miss.
Yeah,
Kay
pero susunod
on
presentation ka ha. Unsa man? Sige, read the question. Di, unsa man? Unsa man?
my question here is describe in your own words the meaning of the word ideal as applied to a device or a system. So what I understand from that question, Miss, is ideal in terms of a device, Miss, or a system is like an approximate to what it should behave as in terms of a real system is or real device. It is mostly like an example, Miss, like it is like a basis to what it should probably behave. The behavior of it, it it is a basis to what it should behave as in the real world, but it isn't like always gonna be the correct one, Miss. Like it isn't gonna be the perfect like system is or dili like dili siya ideal jud kuan, Miss ba? Dili siya practical nga kuan.
Check. Ideal is, unsa to?
Ideal in terms of a system lang, Miss,
Ah,
is kuan. It is like a basis or an approximate of what a real device or system should behave, Miss.
check. Check. Usually, you mentioned it siya. Okay, if we are going to analyze a device or a system, we usually use an ideal situation. One is to simplify our computation. Diba? For example, sa physics, ka na maiksa-iksa o sa naka-computation, maiksa-iksa o stone or bula. Then we solve for the acceleration, the displacement, etc. We use the equations that are derived are in ideal situation. Wala niya gi-appeal ang air resistance, maiksa nimo sa bula, and other factors. The wind direction, check, okay na si Stales. After Stales, rep 2.
Makita ra, Miss. Hello.
Yes.
Okay. So, hello everyone. My name is Carl Repdes. So, I am present. I will be present the question number 25. So, the question is: describe in your own words the characteristics of the ideal diet and how they determine the on and off states of the device. That is, describe why the short circuit and open circuit equivalents are appropriate. So my answer is an ideal diode is the one that acts like a perfect conductor in the forward bias and perfect insulator in the reverse bias. So it is to control the direction of the current flow. So it is like a one-way valve that the substance can pass through or can be black. So in the case of forward bias or when the device is on, the current flowing is greater than zero while the voltage across the diode is equivalent to zero. Thus, the diode acts as a short circuit. So, the short circuit equivalent is appropriate since the resistance between the anode is equal to zero and also the voltage. So, therefore, it conducts current to flow. So, in the case of reverse bias naman or when the device is off, the current is equivalent to zero while the voltage across the diode is less than zero. Thus, the diode acts as an open circuit. The open circuit equivalent is appropriate since there is no current to flow, therefore it does not conduct. So for visualize, mauni ang anodes, then mauni ang cathodes sa ang kanang example kay ang voltage ani niya kay is being neglected or ang voltage kay equals to zero or less than to zero. So when the device is on, the switch is closed, and the current will flow forward. So in the reverse bias naman kay if the switch is off, the current will not flow since open circuit man siya. So, mara to miss.
Check ang sa 2.7.
Ay, kuan to miss kanang voltage miss.
When the diode is on, ideally, it is a short circuit, so no voltage can be measured. However, in the practical world, again, um, there is a voltage that can be measured across the diodes. Gamay lang jud siya around. If our diode is a silicon diode, it's around 0.7, 0.65 or 0.7 volts. Sakto to. Approximate model to ang 9.7. After dos, Oracoy. Si Oracoy.
Miss.
Will na mag-start.
So, good morning everyone. I've been assigned of number 26, importance between simple switch and ideal diode. Simple switch A switch is a specific device that allows electricity to flow or prevents it from flowing when it is not desired. For example, when a switch is turned on, it allows an alternating current to pass through without changing the waveform. So that is a simple switch. Next is ideal diode. An ideal diode is a diode that works as a perfect conductor when forward biased and as a perfect insulator when reverse biased. For example, so when positive voltage is applied across the anode to the cathode, the diode conducts forward current instantly. When voltage is applied in reverse, the diode conducts no current at all. So, more to ang ideal diode. More to is
Check to siya. Again, a diode is like a switch. Kung i-reverse bias off, kung i-forward bias on. Um, the difference is that if it is on, the direction of current is only one way. Di parehas sa ordinary nga switch that it doesn't pwede siya both ways. Ang sa diode lang kay isa lang jud ka direction ang current when it is on. And then Soliano, Jade. Na si Jade Soliano. Saan ba na makita ng participants? I think Soliano is not around. Wala si Soliano. So today, ang absent si Soliano. All others that were called to present are around. Check. Again, this wraps up our meeting for today. Please, again, don't forget that we have a test next week. Please make yourself available online. Okay, walay special test. And the test will start at 8. And please tell those who are not around, both friends and enemies. Ox, unsay lain concern pa for our subject?
Miss.
Sige. Thank you for your time today. Wala na concern, pwede na mo leave. And I will also be ending the call. Again, next week we will not meet kay magtesta. Salamat.